For this experiment, this is the circuit diagram. This is transistor, this input capacitor, base capacitor R1, R2. This R3, R4 are connected from the generator, and by potential divider arrangement we have to make the connection with the help of this R3, R4. So from generator, from here we have to make connection to this R3, R4. This is the circuit diagram for C amplifier. With the help of this meter we have to measure the output voltage, and from this battery, for biasing of transistor, we have to make the connection 9 volt to this transistor circuit. From this battery positive, use the red wire for positive and black for negative. Connect to this terminal where it is written 9 volt positive. This is DC voltage. We have to make connection over here. Negative of this battery power supply, DC power supply, connect it to the ground. So biasing voltage is connected to the transistor operation. This terminal, middle terminal, red terminal, connect from here to this R3, R4 voltage divider combination. Terminal lower one, connect it to this potential divider arrangement of R3, R4. Terminal of this potential divider arrangement, input of this circuit. This meter, we have to first measure the input voltage and record the output voltage. Biasing voltage, we have to measure 9 volt over here. From this battery, adjust the 9 volt, switch it on and adjust the voltage of battery 9 volt. This is DC, so keep it on 10 volt DC and use the black line for measurement of this. So 10 volt DC, you have to adjust 9 volt. So this is 6, 8 and this is 9. This is the 9 volt on black line and 9 volt is adjusted from this battery. Switch on this knob and adjust the input voltage of this frequency generator near about 20 or 30 millivolt. So this is the range selector which is selected this millivolt range. Here it is millivolt, and by using this knob adjust it 30 millivolts. Is this 20 millivolt? So this is selected range of 30 millivolt. This is 0, 10 and 20 millivolt is the input adjusted. This is the frequency selector. This knob indicates the first digit. This is the pointer. This is on 0. This 10 plus whatever this pointing into, this is frequency multiplier. So if I keep it at 0, so this is at 10, 10 plus 0 is 10 into, if this knob at 1, so frequency is kept 10 Hertz. So this is the frequency selection. This plus this into this. So this is the frequency we selected, and for this frequency output is recorded on AC scale. This is selected 10 on red AC, and read the red line. This is 0, 1, 2, 3, 3.8 volt is the output for this input voltage. Frequency and record the output voltage. You will find that the output voltage is going on increasing. It will remain constant, and for high frequency it will come to low voltage. Increasing, it remains constant and then decreasing. Divide the maximum value by √2 and find out the corresponding value over here that shows the first frequency F1 and this higher frequency F2. The difference between these two frequencies is the frequency band. Then output voltage divided by input voltage, which you kept constant, you will give a gain. So first you have to convert this millivolt into volt, then divide by this millivolt to this, and then find out the value of gain. So 20 millivolt multiply by 10 raised to minus 3, it will get converted into volt. So 0.8 divided by 20 into 10 raised to minus 3, and for that calculation you have to find out this gain for each voltage. You will find for higher frequency, as you are going on increasing up to 1000k, you will find that values are remaining constant and then reduces to low value. For that, corresponding gains has been found out, and the graph is plotted for gain and frequency, and from this you have to find out the frequency log of f1 log f2 and take the anti-log of that and find out the delta f, that is the bandwidth between these two. You will get the results from graph, and by calculation both frequencies are getting same. So this is the result from theoretical value, and this is the frequency from graphical value. Both are perfectly matching, and this is the C amplifier bandwidth.